Assalamu alaikum, my dear students. I hope all of you are fine and having good health. Today we have the lecture number 14, that is from Fundamentals of Chemistry, and the topic we have it is empirical formula and the molecular formula. So let's have a look at what does mean by empirical and the molecular formula. Basically, when we have a look on the empirical formula or when we have the types of formulas, basically we have two types of formulas. The number one type we have it is the empirical formula, and the second one type we have it is the molecular formula. So we have two formulas to represent the compounds. To represent the compounds we have two formulas, empirical and molecular. So let's have a look at what does mean by the empirical formula. So the simplest type of formula it is known as the empirical formula. It is the simplest type of formula, that is empirical formula. So by definition it is the formula that gives the simplest whole ratio, that gives the simplest whole number atoms ratio of atoms, and these atoms are present in the compound. So when we have a compound and we need to write its formula, so the formula that gives the simplest whole number ratio of atoms, that formula is known as empirical formula. So the empirical formula of a compound is also determined by knowing the percentage composition of compounds. We can also write the empirical formula by knowing the composition, that is percentage composition of the compounds. So here we have many or different examples that are going to denote the empirical formula. For example, we have two types of compounds. The number one we have the covalent compounds, and the second one we have ionic compounds. So what is difference between the ionic compounds and covalent compounds? The compounds that are formed by mutual chaining of electrons are known as covalent compounds, and the ionic compounds that are consisting of ions, and here is the involvement of loss or gain of electrons. So this is the ionic compound. So let's discuss the examples of the empirical formula. So empirical formula for the covalent compounds. For example, we have a simple compound like benzene. Here we have C6H6. Its formula is C6H6. So here it is having the ratio of atoms, that is 6 ratio 6. But if we are going to simplify that, then we will found that CH. So this formula is having the ratio 1 ratio 1. So in this formula we have the simplest whole ratio of atoms of carbon to hydrogen. So this is its empirical formula. When we are going to talk about the other formula, that is having ratio 6 ratio 6, this formula we called it as the molecular formula. So the empirical formula that gives the simplest whole number ratio for the covalent compounds, basically we have the simplest whole number ratio. Another example, we have silica. Silica, basically it is the sand. So now have a look. We sand, what is its formula? As SiO2, where the ratio of silicon to oxygen is 1 ratio 2. So this is its empirical formula because it cannot be further simplified. So this is the empirical formula, the silica, that is known as sand. The sand, we also have a lot of sand around us in the deserts as well. Next, second example for this we have it is glucose. So glucose, its simple formula we have C6H12O6. This is its formula. Next, how we can simplify that? By simplifying we get CH2O. This formula is known as its empirical formula, and the ratio of atoms over there is carbon to oxygen and hydrogen we have 1 ratio 2 ratio 1. So the ratio that gives the simplest number whole number ratio of atoms of elements present in the formula, it is known as the empirical formula. So here the CH is a simple empirical formula, C6H6 is the molecular formula, and it is its structure formula. That is for benzene, as it is a hexagonal structure like this, and it is having 3 double bonds. Next we have the formula for the ionic compounds. So the formula for the ionic compounds is basically known as the formula unit. The formula that is going to represent the ionic compounds is known as the formula unit. And next, the empirical formula for the ionic compounds is also known as the formula unit for the ionic compounds. Let's have it is also the simplest whole number ratio of ions. And here we have the simplest whole number ratio of the ions because the ionic compounds are made up of ions. So we have the simplest ratio about the ions. For example, if we have a table salt, its formula is NaCl. Here the ratio is 1 ratio 1. On the other hand, all the ionic compounds just have their empirical formula. Here the sodium chloride, if we have the potassium bromide, KBr. The ratio is 1 ratio 1, so it is its empirical formula. We have another example like calcium chloride. Here the ratio is 1 ratio 2, so this is its empirical formula. Next we have the molecular formula. So the molecular formula is basically the formula that tells actual number of atoms present in the compound. So molecular formula tells us about the actual number of atoms. Actual number of atoms, how many number of atoms are present. For example, if we have glucose C6H12O6, here the ratio is 6 ratio 12 ratio 6. So this formula is its molecular formula. But if I'm going to simplify that, I will get CH2O. So this is the simplest whole number ratio of atoms. This is known as the empirical formula for that compound. So molecular formula tells the total number of atoms present in the formula. Some compounds have same molecular formula as well as empirical formula. Likewise, we have H2O. Its empirical formula is and molecular formula is same, that is 2 ratio 1. If we have the carbon dioxide, its molecular and empirical formula is same, that is 1 ratio 2. So the compounds may have same molecular formula or different molecular formula or empirical formula for the given compounds. Next, we have the relationship that is between the molecular formula and the empirical formula. So the relationship between empirical formula and the molecular formula, as we have, if we know the empirical formula of the compound, then we may be able to find the molecular formula for that from the given information. And the formula that we used is molecular formula. Molecular formula is equal to N multiplied by empirical formula, where the N number may be changes from as 2, 3 and so on. For example, here we have the example of molecular formula for glucose, that is C6H12O6. By simplifying it, we just get CH2O. Then how we can get the molecular formula for from this empirical formula? So we will multiply or use the formula this. We will multiply 2 into CH2O. That is the empirical formula. It is the number N. Now we will have the molecular formula for this as C2H12 here we have basically number of n, 2, not we will take 6. So we will multiply over it with this 6. So we will have CH2O, then C6H12O6. It is the basically molecular formula for the glucose. So you can find the molecular formula from the empirical formula. I hope you guys understand about that. If you have any queries, you can ask me about that in the comment section and I will get back to you guys soon inshallah. For that time, have a good day and Allah Hafiz.